Welcome back to Benny's Custom Works. Today we've got a special bonus episode. We're on location at Hughes Performance in Arizona in the US. We've also got Pete Nichols here with us, and today we're going to tackle some pretty awesome automatic tech questions. We decided to put the questions out to you guys on social media, and we got the top 10 questions of everyone out there. We didn't pick every single one because there's a few pretty oddball questions that may or may not even have an answer. So Pete's going to give us the rundown of some basic info.
Yeah.
As I said, we picked out even some of those are my questions, so we'll run through them and let everyone know what's up.
Fantastic.
So straight off the bat, how does a lockup converter work, and can you retrofit it to a transmission?
Great question. So you have two different lockup options. When you're dealing with OEM torque converter lockup technology, you're using turbine pressure, which is the turbine here, to apply the lockup clutch, which is right here. You have a solenoid that is feeding fluid pressure into the converter through a hollow gun drill through the input shaft, and it's holding this clutch off. When you shut the solenoid off via the ECM, that fluid flow shuts off. The natural thrust pressure generated between the impeller and turbine physically forces the turbine and the clutch into the cover, causing the converter to lock up. And that was originally developed as a emissions and fuel efficiency device. When you get into drag racing lockup converters, where you are retrofitting lockup to, say, a Power Glide or a Turbo 400, you actually have a clutch pack inside the converter, similar to what you see in the Power Glide here. And that clutch pack actually uses fluid pressure to apply instead of to hold it off like the OEM technology does. And really only the Power Glide and 400 have been adapted for the drag racing lockup converter technology. Yeah. There's nothing else out there that's really strong enough in terms of input shaft strength to handle that multiple clutch pack banging on behind 2,000 or 3,000 horsepower going down the drag strip.
So I guess going backwards from that a little bit, at this stage there's no street style retrofits for, say, C4s, C6s, things like that.
So there is a company out there that did develop that technology, and it uses a centrifugally applied damper clutch similar to what you'd see in like an AOD transmission. I don't honestly know if they're still doing it. It was a pretty neat idea. I don't think the idea ever really took off.
Yeah, just not enough demand for it, maybe?
Yeah, exactly.
Yeah, cool. Can you have a converter with the same stall speed but a smaller body diameter?
Absolutely. So when we get into different stall speeds with the same core diameters, we're dealing with impeller fin angle here. As we go more positive, we're lowering stalls. We go more negative, we're increasing stall. We're dealing with different stators with different vane counts and angles, and we're dealing with different clearances between all of the elements to help establish stall speed. So for the customer that might want, say, a lower stall speed torque converter, but in the smaller diameter core like what you see here as compared to, say, an OEM 12-inch style core, we'll go in and we'll pull this fin angle more positive, or use a pump that has a more positive angle right from the bat. We'll use a stator with lower vane counts or a more aggressive vane angle. We'll tighten up the clearances to provide that lower stall, small diameter converter. The advantage being that as you reduce converter diameter, you're reducing mass on the back of the crankshaft, so you have less rotating weight. That can provide a little bit crisper throttle response, a little bit crisper engine response all the way through the rev range, a little bit less RPM drop on the gear change, so the engine's spending more time in the power band. That doesn't mean it's a fix-all for every application out there. That's why you want to deal with a converter builder so they can recommend the correct diameter for your application.
How does a trans brake work?
So a trans brake hydraulically applies low gear and reverse at the same time to internally lock up the transmission so that the drive shaft can't turn. That way you can achieve maximum staging speed against the converter without overpowering the braking system and the rear tires. In a Power Glide, you'll have the band on, which rides on the drum here, and then you'll have the reverse clutch pack on. In a Turbo 400, which is obviously a really popular trans brake application, you'll have the forward clutch pack, the direct clutch pack, and the rear band on. And it's just basically a hydraulically actuated mechanical lock inside the transmission.
The Cresta transmission obviously is a reed case turbo 400 that you guys built for us.
Right.
Actually has trans brake first and second. Why is that?
So having the first and second gear trans brake capability allows you to have a variety of starting line ratio. You can launch in first gear or second gear. So in your example, if you were going to go out to the airport drags that they have in Australia, where you have a really challenging racing surface, you could effectively launch it in second gear to reduce your starting line ratio, and you're reducing hit to the tire, and you're basically using it as a traction aid. Same goes in no prep racing, which is real big here in the States. Street racing, the 1+2 trans brake option is really popular for that reason, just to help manage traction.
Yeah, to be perfectly honest, I haven't used it yet.
Right.
But obviously being that we're going to take the car back home, the runway events are kind of up there to do, so handy to know that that's actually what it's for.
Perfect.
Still on trans brakes, why would you have the solenoid in the pan as opposed to externally on the transmission case?
So on a Turbo 400, you have really long hydraulic circuits that you're having to fill up when you have a conventionally designed trans brake with an external solenoid. By going internal solenoid and redesigning the valve body to our billet piece, we can shorten all those hydraulic passageways, and it makes for a much faster reacting trans brake. It not only sets faster so you can stage quicker, but it releases faster so you can cut a better light.
The tree killer.
Yeah, exactly.
So we've touched a bit on conventional 2 and 3 speed transmissions, but there's also hybrid transmissions like the 2-speed 400, and you've also mentioned the 5-speed 6L80. What are the benefits in doing that on either a street or a strip application?
So in a 2-speed 400, you have more ratio options to help tune your starting line ratio than you do with a Power Glide. Currently, the numerically lowest ratio that you can go with in a Power Glide is a 1.58 to 1 in first gear. With a Turbo 400, we can do 1.56, 1.48, 144, 140, all the way down to 131 low gear.
Wow.
So if you have say like a Pro Mod car, for example, that's making an honest 5,000 plus horsepower, something with a 131 low gear is pretty appealing to that type of application, just to help manage the hit at the starting line.
Yeah.
And again, 2-speed 400s are real popular in traction limited racing, whether it's no prep or airport drags or what have you. Again, to control that ratio in first gear, that's where those really shine. Generally speaking, on a 2-speed 400, you don't really start to see benefits until you're making 1,400 horsepower and really striking the tire really hard.
So it's not really a traditional street transmission as such.
Yeah, it can be driven on the street with no issue, but because there's so little first gear ratio, it's going to feel very different from the driver's seat, and not a lot of people are a fan of that.
Yeah, cool.
As far as the multi-speed transmissions like the 6L80s and 6R80s and 4L80s and that type of thing, you can do a 5-speed conversion in a 4L80, which works pretty well in like a towing application if you just need an extra gear split between ratios if you're climbing up a steep grade. 6R80s, you can actually go backwards and go to a 4-speed these days, take away starting line ratio, get rid of the 4 Series first gear. So if you have a late model Mustang that's factory equipped with a 6R80, making 1,400 horsepower, running 8s, you don't need all that ratio, but you want to keep the 6R80 in the car. You can do that by converting it to a 4-speed.
Yeah, cool. So that basically maintains your factory transmission footprint, but gives you strength in different ratios.
Exactly.
Yeah, right. Yeah, it's an interesting concept, and it's not really something I'd looked at or thought about, especially when we were doing the Cresta. It was just Turbo 400 was what the car had always had.
Sure.
And I guess we're not really at the limit of the 400 yet. And,
not at all.
And obviously having the second gear trans brake, that's probably a little bit of a stopgap as opposed to just going a full-on 2-speed 400.
Absolutely.
Yeah, so reverse pattern versus conventional pattern autos, why?
It really just boils down to preference. Some guys like a reverse shift pattern and like to be able to pull the shifter handle towards them as they're changing gears. Some guys like the conventional and still push when you're dealing with manualized valve bodies.
So there's no performance benefit, it's purely a driving preference?
Yeah, basically. Yeah, you can set up the transmissions to run at the same exact line pressure, use all the same hard parts. You're not really giving anything up in terms of strength these days. Back in early automatic performance development, there might have been some differences where reverse pattern might have offered an advantage, but yeah, it's just preference.
So just touching back on the Cresta again, we've recently fitted a transmission converter dump valve. What is the benefit to using something like that in a drag racing application?
So a dump valve is pretty cool. It does a few things for you. It bleeds off converter charge pressure when you're staging against the trans brake. That reduces load against the engine thrust bearing. So in an engine like a Barra where you have a sensitive thrust bearing, although not in your case with the roller bearing, it helps preserve the life of the thrust bearing. And because we're dumping converter charge, we're actually cavitating the converter. It's not running full of fluid while you're staging, so you can get an increase in stall speed. You can also activate the dump valve down track, like on the gear change, if you want to maintain more drive shaft speed, or if you're in tricky traction conditions, you can actually use it as a traction aid device.
Yeah, right.
By bleeding converter off.
Yeah, fantastic. We've covered a lot of drag racing stuff today. I guess we should probably mention some street options.
Sure.
Choosing the correct transmission for a street car, there's so many options. We've got Turbo 350, I know Al's mentioned that before, and the 4L80 and the 4L60.
Right.
Can you kind of give us a quick rundown on which of those would be suitable for mild street cars and why you would go either of those?
Right. Well, there's really no wrong choice. A lot of customers will just order based on what was already in the car because that's simple. You don't have to change drive shaft or mounting.
Yeah.
Overdrives are obviously really popular for retrofitting. So if you have a muscle car that say had a turbo 350 in it, retrofitting a 700 or even an electronically controlled overdrive is a nice option because you have better freeway manners. But we really cover all the bases. Turbo 350s, we have everything from 500 to 1,000 horsepower builds. We get into the Fords and Mopars too, the C4s, the 727s. It really just kind of comes down to preference. What the consumer wants, what's the best fit for their budget, what's the best fit for their chassis.
Yeah.
And we just work with every individual as if it's a custom build.
Yeah, I guess you've already just touched on my lead up to that was going to be going back to some of the smaller transmissions like the 350 and the 700, for instance. They're perfect for smaller factory body cars as opposed to the larger transmissions where you may need to cut the tunnel or bigger bell housing clearances. So trying to maintain that smaller footprint but holding power is obviously key.
Absolutely.
Especially if you're doing like a resto or a street car that's quite nice. You don't want to be cutting and putting like aftermarket sheet tunnels and things like that in.
100%.
So
absolutely.
Yeah, fantastic. Well, you've answered all my questions and then some. Alan has a question. Alan wants to know how you keep a 4L60E alive.
Great question. I know that's probably universally the most hated transmission out there, commonly referred to as a box of neutrals.
Yeah, I've seen that meme getting around the internet.
They're rubbish in stock form.
They're worse than Subaru manuals.
Yeah, they're pretty bad in stock form, but in modified form, they're actually a surprisingly capable transmission.
Yeah, cool.
We actually offer options all the way from 500 to 1,000 horsepower build on the 4L60E that we actually give warranty on at that power level.
Wow.
The problem is that it's a very expensive build because you're literally reusing the case, a
and
few of the
else.
OEM hard parts, and billet everything front to rear. There's another company that all builders use, Sonics. They produce parts. They've really mastered the 4L60E parts game and produced tons of cool stuff for them that will actually make the 4L60E live. So when you buy a high horsepower 4L60E, you're buying a whole box full of Sonics parts that work really killer.
And you mentioned off camera to us previously that you guys actually supply a controller for that.
We do.
To allow retrofitting, not just an OEM type replacement. So you could put that in your old Camaro or even Holden GM products in Australia because we run turbo pattern over there as well.
Absolutely. Yeah, if you want to put a 60 or an 80 into an old carbureted vehicle, our controllers allow that. And they come with a throttle position sensor kit. They're fully programmable. They're easily programmable. It has really user-friendly software. We offer two different kits. One you can tune right on the interface of the controller or through your PC. The other tunes through a smartphone app.
Yeah, nice.
Really simple to use.
That's fantastic.
Yeah.
You got any more questions, Alan? That answers all our questions. Thanks so much, Pete.
Thanks, mate.
It's been fantastic for being here, one, and also all your support with the Cresta and all the crazy stuff we've got going on.
Yeah.
Anyone that wants to see more in-depth automatic transmission tech, please check out the Hughes Transmissions or Hughes Performance YouTube channel. There's so much stuff on there. I haven't even watched all the videos yet. There's tons of stuff about torque converters. We'll chuck a link in the description. Thanks again, Pete.
Thanks, mate.
Really appreciate it.
Phoenix Custom Works.
See you guys next time.
#1.